vectors. So in vectors, you guys understand vectors. Most of you are doing physics. So you know what it means when someone says a vector. Okay? So for us in math, we're just interested in looking at the properties that surround the same vector that you know from physics. And we just use simple notations. We give you a line and give you a point A and B. We're going to say that AB as a vector. So now we'll say AB, that's a vector now. If we give it the direction, so that arrow there is pointing there, that we're moving from A to B. And so if you're given A as a point, say 1, 2, and B as a point, 7, 11. For you to find the vector AB, you say 7 minus 1, and then 11 minus 2. And this vector can be written as 6, 9. You can as well write it as 6i plus 9j. If the direction was to change, then our vector will also be written as BA. How do they relate? Let's see. We'll have 1 minus 7, 2 minus 11, giving us the vector -6, -9. If we write it in this form, we'll have -6i minus 9j, so that we get -6i plus 9j, telling us that this guy is just a negative of AB. So if you change the direction, then the signs also will change. Now suppose this vector you're using here, let's call this vector to be, okay, the same way it is. Now I want to find its magnitude. The magnitude of AB, this vector, is going to be denoted as this. And then it will be the distance where you get 6, square it, get 9, square it. So you understand that in terms of the magnitude of vector BA will be the same, because even here we'll say -6 squared plus -9 squared. So the scalars, the numbers coming out will be the same. So here we have 36 plus 81. Here we have 36 plus 81. Giving us what numbers? In this course, we use calculator, so we can punch and get 170. The same thing will happen here. So what we have learned here is that 1, how to get a vector between 2 points from here. 2, how to get the magnitude. 3, that the magnitude of AB is the same as the magnitude of BA. We have also learned that this AB, if you change the direction, we'll get negative BA. You must be okay this far. I mean, so that if you, because you have seen that these vectors A, B differ by a sign. Any concern? So since I've seen that these guys differ by a sign, if if you add this, you must be able to get 0. Since they just differ by a sign, so it's like you have gone, you start from here, so when you come back, by the time you are here, it will assume that work done is equal to 0. Okay, so at least you have done 3 things. In the next page, we'll look at what do we mean when we say vectors are parallel. So,
Excuse me, sir.
yes.
Could you please go back to the previous slide? Thank you.
Okay. So we're saying parallel vectors. Vectors A and B are said to be parallel to each other. If you can write A as a scalar multiple, if you can write A as a scalar multiple, if there could be some number where this T is a scale, if there is to be some number T, that when you multiply B by T, you get A. Then you say that A is parallel to B. Another way of saying that is if this vector A is given as A1, A2, A3. Vector B is given as B1, B2, B3. The other way of saying that A and B are parallel is by saying that A1 over B1 will be the same as A2 over B2. And this must be the same as A3 over B3. So we have 2 ways of knowing if they are parallel. You can look for a number T, multiply by B, you get A, then they are parallel. Or if T is an issue, you get the component vectors and divide, you must get the same number. Ratio test. Perpendicular. Vectors A and B are said to be perpendicular to each other if when you multiply A by B, you get 0. And when we learn to find the angles, if the angle in between them is 90, Then you say that these two vectors are perpendicular. What we mean by dot product? We mean if A is vector A1, A2, and B is vector B1, B2, then A dot B is defined as A1, A2 dot B1, B2, which is the same as A1 multiplied by A1, B1 plus, this is no longer a vector, it's a number now. A1, B1 plus A2, B2.
Excuse me, sir.
Hello.
Yes, I'm kindly asking if you can just explain on top, the top part.
The top part, two vectors A and B are said to be parallel if you can write the vector A as a product of T and B, where T is just some number, maybe 2, 3. If you can find that number and then multiply by B and you get A, then you say that A and B are parallel. Or if that is too much, then you get the components of A. I'll give you an example. Okay, let me give an example. Let's say A is 4, 6, 8, and B is B is 2, 3, 4. You want to check if these are parallel. You can check, are we able to write A as a product of some number by B? Let's see. A is 4, 6, 8. And then we'll look for some number T that you can multiply by this to get 4, 6, 8. Okay? If this is too much now, then you say, okay, maybe it will be too hard for me to get T, or I don't have time to start solving equations. Then you're allowed to get 4 divided by 2. The first component divided by the first component. If what you get will be the same as 6 divided by 3, to be the same as 8 divided by 4. If this will be true, then you say that A is parallel to B. Now for sure here we are getting 2. If you decided to solve there, you would have said, okay, I have 4, 6, 8 is equal to 2t, 3t, 4t. Then again, you're saying the same thing. So 4 should be equal to 2t. 6 should be equal to 3t. 8 should be equal to 4t. So if you divide by 4, divide by 4. Divide by 3, divide by 3. Divide by 2, divide by 2. Because t, this is the same t, so t should be equal. So we have t is equal to 2, t is equal to 2, t is equal to 2. Meaning that A and B are parallel. If you are checking that they are perpendicular, then you get a dot product. An example here. An example, the dot product. You get A to be a vector, say 2, -3, 1. And B to be a vector, okay, anyway, 1, 1, 1. Are these two vectors perpendicular? You get A dot B, and you have 2, -3, 1 dot 1, 1, 1. So you say 2 times 1 plus -3 times 1 plus 1 times 1. This is 2 plus 3. I mean, this is -1. So 2 minus you say A is parallel to B or B is parallel to A, or A and B are parallel to each other. So here we have 2 minus 3 plus 1, which is equal to 0. Because A dot B is 0, we say that A is perpendicular to B, or B is perpendicular to A, or A and B are perpendicular to each other, or A and B are orthogonal to each other.
Excuse me, sir. So perpendicular vectors are orthogonal vectors.
Yes, so that perpendicular and orthogonal is the same thing.
All right, thank you.
Okay. Another question? Any other question? Okay, so we have parallel vector.
Is there any other way of proving if the vector is perpendicular or not?
Not the vector. If vectors are perpendicular to each other or not, we can use the angle. We can use the angle. How do you find the angle?
The angle, it's the dot product of the two vectors divided by their respective magnitude.
Very powerful way. Okay, before we get there, there's what we call the parallelogram law. Oh, it's a rule. This rule here, saying that thing you say U plus V as a vector is actually coming from having a structure of this form, where you say, okay, I have this as vector V, and then I also have this as vector U. So this, I can put it well, parallel, of course, to each other. And then this guy comes to cut there. This is a parallelogram. So now I'm saying the thing we call U plus V, because this is also U. This is V. That is U. If you have a line in between here, we say this line is U plus V. So when you're adding vectors, this is what you actually mean. Okay? You are moving in this direction. You move from, if I put a point P here, you are moving from P to point R. But you want to pass through, you start from P, you pass through M. So you move in this direction, and then using U, you move from P to M. And then using V, you move from M to N. Or you can put another vector here. You can still move in the same distance. You go to N, then you go to R. So this movement will give you the same distance as having the shortcut that you may think maybe the shortcut, but no, it's the same thing. Because the angle there is not 90. And then, now we go back to high school. If you have a triangle, with side B, and these are angles inside C, A. Then the sides, we call this side A, this side B, this side C. Then you say that the sine law, which is where now we obtain some angles. You say A over sine A should be equal to B over sine B, which is equal to C over sine C. And the cosine law will just give you, if you want to find the distance of C, if you want to find C, then you should get the square root of A squared plus B squared, and then subtract the 2 multiplied by A and B, and you get the cos of C. So you can be asked anything at once. So in case you're given two vectors and an angle, suppose you're given something like this, and you're given an angle 30, and here you're told this is 3, that is 4. Then you must find this side. Then you use cosine law. Because you have this side, 3, you have 4, where there is A and B, and then you cos C, you use the angle, then you get the distance, that is answer. Or if you are given or you can be given two angles in one side, then you're asked to find the other side. You must be able to do that. That's not a big task. Any question?
I have a question, sir.
Mm-hmm.
Does it mean that you can only use the cosine law when you have two vectors and one angle, and you can only use the sine rule when you have one vector and two angles?
For a sine law, For a sine law, you can use it in any way. You can have two angles in one side, or two sides and one angle. But if the angle is in the middle of the two sides given, then you use cosine law to get the other side opposite at the given angle.
Explain again how this cosine law works.